So this is a brief update to my last video where I was talking through this pseudo PIB, kind of mimicking PIB functionality and getting that to work. And I have a nice update. I do have hardware PIB now working with maybe some updates on intended architecture that really helped. So one of the things in my last video I had mentioned was that I was using Microsoft Copilot that was finding information that I could not find through Google or other searches. David L. had posted a note on this last video and just maybe suggesting to go check out Gemini and see if it would find some other pieces of information that would be helpful. So I did start up a conversation with Gemini, and it was way off base when I started the conversation. But after a little bit of back and forth, it started to dial in pretty well and understand things. And it came back with some comments that I have here on the screen, and this was tremendously helpful. So basically, it's suggesting here that really Western Design Center's intention with this was not that the 265 would be a master, but really that it would be the slave. So there'd be a bigger, more powerful CPU driving it, and that there isn't actually hardware PIB support in the 265 to be a master. That hardware support is to be a slave. And that if you want to treat it as a master, you really have to do it the way I was doing it in the last video, which was the pseudo, me doing the bit banging to give the right control signals to be a master. So that was tremendously helpful in just my thinking of this. So what I've done is I've now gone and updated my master a little bit, but I'm basically doing the manual control of the signals. But I did have to add in something to tell it which mailbox, and I'll show you what that looks like. And then on my slave, I've updated that to truly use PIB, to use the hardware PIB for auto negotiation or the auto handshaking, and it's all working. So let me just real quick show you. I'll turn on my system. And you're not going to notice, hopefully, any differences from the last video. But what you're going to see here is that when I come in here, and maybe I'll pull up my two terminal programs. So here's one, here's the other. They initialized, so the one on the left initialized, the one on the right. But as I type keys, hello, you can see that the functionality is still the same as what it was in the last video. Let me jump back though over here and just explain something. I had shown a graphic like this talking through the ports from my master to the slave. But I want to reinforce that on the master, PIB needs to be disabled because it doesn't have master support for PIB, is what Gemini was suggesting, and that really does match up with everything that I've been seeing. So I'm going to say I support that comment that there is not master support hardware-wise on the 265 for PIB, just slave support. So I've disabled PIB on the master. I have it enabled on the slave. So I turn on the master. It holds the slave in reset. I configure the PIB, which basically means leave it disabled, but do all the manual port direction and port output. Let the reset release, and then on the slave, configure PIB, which is enable PIB. And then I write my data to the data port, which is port 5. And then here I change this a little bit. I have to select which mailbox, which is this PIRS. So which mailbox on the slave do I want to write that data to? So like in my case, I'll show you the code real briefly, but I'm going to say use mailbox, this PIRS 7. And so then I have to select that in my control line. So on port 4, the top 3 lines are to select the PIR. So I'll set that to a 111, which means 7. So then I'm saying when I write this data, I want you to put it into slot 7, essentially. And then I assert the same chip select and interrupt that I did in the last video. And then at that point, the interrupt is properly running on the slave. I no longer have it tied to a port 6 edge, like a port 6 pin 64 like I did in the last video. I'm just using the built-in port 4 interrupt management for PIB. So it's the PIB interrupt service routine or vector that I'm using that goes to the routine. And it's automatically doing the acknowledgement, so I don't have to worry about that. And I just simply fetch the byte, and you're going to see that the slave code now is really simple. And then basically go back to idle. And so if I go now to my code, let me first of all pull up the primary. So the primary is very similar. I've trimmed it down, just taken out some noise that was in here, but basically I come in here and I initialize my PIB, and the initialization just says, okay, on port 4, I want these outputs and inputs. Again, these bottom two are for NMI and IRQB. This one here is for the acknowledgement coming back from the slave. The rest of these are outputs. And I mentioned the top 3 bits are for which basically which mailbox do I want to put it in. The other 2 are these interrupt and basically notification that, hey, I've got data and I'm going to interrupt you. Why don't you do something with it, slave? I mark my data port as output. I turn on PIB. So like in this case, first of all, I clear the PIB flags, and actually that might not be necessary. So I'll just tag that with a question mark. I don't think that's probably not needed. Well, actually it's the primary. I know it's not needed. So I'm just going to take that out, not needed. Because this PIB FR, flag register, only exists on the slave. There is no purpose for it on the master because the master is not using the hardware PIB. And then I disable, make sure that PIB is not enabled on the master, and then I put it into idle state. Now when I go to send a byte, a little bit of a change from the last video. Coming into this send PIB is a key code, not a key code, an ASCII character. When I hit a key on the keyboard, I print it out to my serial, and then I load up whatever's in port 4, the current control signals, and I OR and add into that the PIRS7 because I want to put it into mailbox slot 7. So this is just going to be 3 1s on those 3 highest bits, and you can see I have these other mailboxes I can basically put it into. So this is saying put it into that PIR7, and I'm just saying this PIRS7 is those 3 bits of value. So put those onto the upper 3 bits of PD4, store it. Once it's there and it's part of the data on that, I then turn around and I drop the 2 signals that tell the slave to react to this, do something with this. And then I wait for the slave to acknowledge and I get out of here. So that's it for the primary. Now, if I go over to the slave then, and I go to the top, you're going to see, first of all, see that this code is 60%, 70% comments now. It really, there's not a lot to it. I init the slave, and on the slave, I'm going to say set the data for the data port as input. And I want to go to the control port, which was port 4, and set this pin as an output. All the others will stay as an input. This is the acknowledgement back to the master. And then I load up the configuration of my PIB. And so in this case, I'm saying enable the PIB, that's the bottom bit, enable automatic handshaking for PIR3 and automatic handshaking for PIR7. So when from the master I say choose PIR7 that I want to send this to, the slave's going to receive it. It's going to see that it's for PIR7, and it's going to go through the automatic input handshaking process for that. And that's it for the init. Now when I go to receive, look how simple this is now. It is 1 line of code. I don't have to do anything else. The rest of this is just normal wrapper for an interrupt service routine. But all I'm doing, well, first of all, the interrupt service routine, let me go just show you what I'm pointing to there, is this one right here, which is the IRQ PIB at FF9C. I commented out this IRQ negative edge 64 that I used in the last video, so completely unnecessary. At this point, it's actually using the native IRQ PIB interrupt, so it's using only signals on port 4 to understand that. It's one signal on port 4. And then over here, the interrupt service routine, all I have to do is directly read whichever mailbox. Now, in this case, I know I'm only writing to mailbox, this PIR 7, so I just simply say read what's in that mailbox and print it. It's that easy. Now, I could write to more than one mailbox. I could have a series of mailboxes filled with bytes, and then here read. On each of those would have its own interrupt, but I could then say, well, check which mailbox has something new coming in. The interrupt is for which mailbox. Well, I can check that by reading this PIB flag register. So I could read that, verify which mailbox this interrupt is tied to, and then read the appropriate mailbox tied to the interrupt because of this flag register. For now, I'm not doing that because I know it's only this PIR 7. But that's it. That is the slave code. So at the end of the day, when it comes to the connectivity between the two microcontrollers, it's really simple. And I wish the data sheet or somewhere there would just been something that said the only thing you have to do is directly connect port 4 to 4 and 5 to 5. Other than that, I've got this reset line control, but everything else is just a direct mapping. Of course, you won't want to bring ports 41 or pin 41 or 40 across. Those, again, are the NMI and IRQ lines. Those are not needed, not used in this solution. It's basically connect port 4 pins 2 through 7 to the other microcontroller 2 through 7, all of port 5, and then deal with your reset however you want to do that. And you wouldn't have to do it the way I'm doing it. You could also have some other type of check from the slave to the master to say, don't do this PIB setup until the master is ready to go. But I'm doing it through this reset, which is simple and is working well. So connectivity actually turned out to be really simple once I got enough pieces of the puzzle put together here. And then the code, again, in hindsight, is all quite simple. It's just you need enough guidance out there in the documentation or somewhere that says, here's what the PIB could look like. It's just the PIB on the slave, and it's very simple to use. And then on the master, you have to treat it basically as a bit bang type of approach. You're not going to have a PIB hardware support to generate those signals. And that's it. And, again, in hindsight, it's like, okay, this all seems really simple, but there were just some missing pieces in the information that made this a little bit longer of a process than it probably needed to be. So I just want to share that quick update. If you're following this, you saw the last video where I was doing the pseudo PIB. The new result is it's really the same master code as I had last time, other than I'm selecting which PIR. I'm selecting the mailbox. And then on the slave, I really gutted what I had there and just simply switched it over to enabling the PIB and then reading the appropriate mailbox on the PIB interrupt service routine. So exciting. Now I can do more with this, see what else I can do, and have confidence that the PCB I was working on that has 2 of these 265s on it, that wiring, or that, the way I've laid out the schematic, should be good to go. I did receive in this VGA circuit, so that's the next thing I'm going to do is now see if I can get this new consolidated VGA circuit working. And if I can, then I think I'm ready to order my next iteration of this PCB for my 265 project that has 2 265s on it. So stay tuned. I think the next video will be on this VGA and whether I have success or not there. So more to come.